What up, what up? Welcome to the AP Precalculus Unit 3 Progress Check A. This is the thing on AP Classroom that tests your knowledge of the first part of Unit 3. If you have an AP teacher, they're probably going to give this to you. So these problems are going to help you get prepared for what this guy is. It's not the exact same problems, but it's problems similar. If you're looking for just making sure that you understand, this is the video. If you're like, I don't know if I understand and I need some extra help, then go watch my reteaching videos. I have two of them for this part. I believe it's 3.1 to 3.4 and then 3.5 to 3.7. Just search Math Teacher Goat 3.1 to 3.4 reteaching or whatever. You'll find it. But that's not what this is. This is basically like, hey, do you understand everything? And this is you just kind of checking to make sure. So which of the following functions are periodic? Well, a periodic function is something that repeats itself exactly. When we take a look at A starts here, goes up, and then seems to repeat itself. So if it starts here, if you're looking at this as the starting point, it seems to repeat itself every two spaces, which means it is periodic, and it has a period of 2 because it cycles every 2 units. So A is periodic. If you take a look at B, you're going to see similar things. You start way down here, you go up and then down and repeat literally the same exact progress. And it looks like in this case, by the time you start at the very bottom, like Drake, and go up way down here and go back down to the same exact spot, it's 3 spaces. So B is going to be part of that too. So A and B are both periodic. However, when you take a look at C, it starts here at we'll just say that this is 1 and then maybe jumps up to 1.5 and then maybe jumps up to 2. And at no point does it go back down to 1 and repeat this process of it jumping up and down again. So C is not periodic because even though it has these waves, it doesn't have the same exact behavior as it did before. So this is a no periodic, no period, nothing like that. Just a big fat no. So A and B on this one, A and B on this one. Those are my guys that are periodic. Starting out strong. Let's move my face. All right, so here we see a periodic function again. Is this the same as the last one? I don't remember. My memory is failing me in my old age. Let f of x be the graph below. So here's f of x. Find the period. Okay, well, you always pick a spot where it's obvious, but you always need to pick spots where the numbers are friendly too. So I'm not going to look at this and be like, oh, I'm going to pick the very tippy tops because I can't 100% sure know exactly what that number is. So it looks like I could just take the very beginning spots and say, let's pick U. We go up, down, up, and then repeat the process, and then repeat the process. So the way you figure out your period is you go from the very beginning to where you begin repeating, and whatever that distance is going to be your period, and in this case, the period is 6. The amplitude is, a lot of people think, oh, the amplitude is the very tippy top to the very bottomy bottom, and that is simply not true. It's the very tippy top to the very bottomy bottom divided by 2. So I'm going to just, make a guess that the very tippy top is 1.75, and maybe the very bottomy bottom is negative 1.75. So the math way of calculating this out would be 1.75 minus negative 1.75, because that's how you find the total height. Divide that by 2. So that would be 3.5 divided by 2, which is just 1.75. Now, the nice thing about this guy is everything is centered in the middle, okay? This guy, as you'll see later on, the line that cuts your periodic function completely in half horizontally is called the midline. And so in this case, it looks like the x-axis is the midline. And when that's the case, when your x-axis is the guy that's cutting something in half, your amplitude is just simply the distance from the midline to the very tippy top. And that is your amplitude in general, the distance from the midline to the very tippy top. So that's another way you can do it mathematically. But when the midline is the x-axis, then really all you have to do is be like, oh, it goes from that to 1.75, and you're done. I just did extra because, it takes more time, and more YouTube time is more YouTube money. Find f of 45. All right, so f of 45 means you go and find out 45. Well, I don't have it. So this is what you do. If you are being asked to find, like, for example, if I were to be like, hey, find f of 4, you would go to 4 and be like, oh, it's 0. Easy peasy. If you were to be like, find f of 1, you would go to 1 and be like, that looks like 1.75. Easy peasy. But when it falls off of the graph like 45 does, the last thing you want to do is be like, all right, well, let's go to 6, or you draw it out, or just keep repeating and see like, okay, well, 20 is going to look like that, and 24 is going to look like that. That just takes too long. What you do is, we know this guy repeats itself and has a complete cycle every 6 units. So what I'm going to do is I'm going to do 6 divided by 45. Now, it seems very, very, very elementary, but watch. 6 divided by 45 is 7. So 7 times 6 is 42. Subtract that. Remainder 3. Now, the key thing here is the remainder 3. F of 45 has the same exact positioning as f of 3. Okay? F of 45 has the same exact positioning. I mean, that makes sense. If I were to do the same thing with f of 8, right? If I divide 6 divided by 8, I would get remainder 2. So 8 has the same exact behavior as 2. I can see that. So f of 45 has the same exact behavior as f of 3. All these dots, let me pick a different color. F of 3 seems to be right there. So f of 45 is f of 3, and f of 3 is 0. So f of 45 is 0. All right? Fun. Fun, 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 fun. All right, let's keep going. Sketch. Y equals sine x. So let's do that. We're down here where I have a little bit of space. Shame on me for not including a blank coordinate plane, but that's all right. I don't need to. Okay, so fun facts about sine, regular sine, is that when there's no number in front of here, the amplitude is 1, invisible 1. This has no number in front of x, so the period is 2 pi. And I know sine, in general, starts out at 0, 0, and goes like that. Okay, so those are basically the only facts that I need to know to make a pretty decent graph. All right, so I'm going to go up to 1, down to -1. Okay, it's going to repeat at 2 pi. So I'll put pi here. I'll put half a pi here. And I'll put 3/4 of a pi here. Okay. And it starts at 0, 0. Sine starts at 0, 0. And repeats at 2 pi. Okay, so it's going to go up, peak out at pi over 2, come back down at pi, bottom out at 3 pi over 2, and repeat. So try to draw the best picture you can. This is absolutely one of my greatest weaknesses, is drawing these things. And so far, I'll give myself a B+, and I'll still keep that B+. That's not so bad. And of course, as you know, with sine, this keeps going, or this backtracks, whatever it is that you're looking at, that's what you have to do. I mean, blah, 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 blah. Okay, so there's my sketch. Where is y greater than 0 on that 0 to 2 pi interval? In other words, where is y positive? Well, y is positive when my graph is above the x-axis. So I want greater than 0, so not including 0, is going to be from 0 to pi. So y is above the x-axis. My graph is above the x-axis between 0 and pi. But since I'm not including 0, I'm not including 0. And I'm not including pi in my interval. That's it. Y is less than 0 from pi to 2 pi. Okay? Does y represent horizontal or vertical displacement? Now, okay, first things first. Y is sine x. Okay, so y is sine x, meaning that sine x, if you might remember, is given to you as cos theta, or like a regular point in trigonometry is cos theta sine theta. Okay, so it's asking here not so much, and it's kind of a bad job by me creating this problem, because I'm accidentally giving away the answer without trying to give away the answer. But what I'm actually asking you is, does sine x represent horizontal or vertical displacement? Sine x is y. So again, bad job by me by calling it y in the first place. If I called it g of x, maybe that would have been a better job by me. But sine theta is y to begin with. And what y does on like a unit circle, okay, like if I was viewing this as a unit circle type thing, if I'm looking at the y value, it's talking about the distance from this to this, whereas I move it along this to this, this to this. So like, I start at 0 and I go counterclockwise and I hit pi over 2, I hit 1, which, matches up with that. And then I go back down, which matches up with that. And then I go underneath, which matches up with that. But basically what I'm doing is as I'm spinning around, I'm really finding the distance from my dot to my x-axis, which is a y value. So this is vertical. Okay, so generally speaking, sine, without looking at this part right here, sine is vertical displacement. Whereas cosine, since that represents the x value, would be horizontal displacement. Okay. So again, not the best job by me creating that problem, but hopefully I explained it decent enough where you're not going to want to throw your computer or phone against the wall. What is the period and frequency? All right, well, whenever you have a trig function, the period we already know is 2 pi. The period of a regular sine or cosine function, for that matter, is 2 pi no matter what. Don't overthink it. The frequency is the number in front of x. So the frequency in this case is 1. So the period is 2 pi. The frequency is 1. Now, what does frequency mean? That means how many times does it repeat itself over a 2 pi interval, and in this case, just 1. So, yeah. Okay. Moving on. Sketch g of x equals cosine. Now, we're going to treat this exactly the way we treated the last guy, okay? We have an amplitude of invisible 1. We have a period of 2 pi, as it always is for regular old cosine. And cosine doesn't start at 0, 0. Cosine starts at 1. That's supposed to be a 1. Ugh. And then goes down and then repeats itself at 2 pi. Okay, and then whatever. So let's draw ourselves a coordinate plane. We're going to go up and peak out at 1. We're going to bottom out at -1, 2 pi, regular pi, half a pi, 3 pi over 2. And then let's draw it out. Okay, start out at 1. It's going to hit the x-axis at pi over 2. It's going to bottom out at -1. Just pretend that that's -1. Check this out. Bam. And then it's going to come back up and hit the x-axis at 3 pi over 2 and then repeat the process at 2 pi. So that's what cosine looks like. And again, it repeats. What A is asking is, where is g of x concave down on 0 and 2 pi? Well, concave up, if you remember, looks like this. Concave down, if you remember, looks like this. The difference between concave up to concave down has an inflection point right here. So basically, I'm looking for the inflection points which appear to be there. That is a concavity and then changes concavity and then has a concavity again. Now, at the inflection points, there is no concavity. Okay, it's neither. So what we're looking at, and so it's kind of like this is a pain in the butt problem because you have to be careful with your brackets and parentheses, is at this very moment at 0, and we are including 0 in our interval. At this moment at 0, we are concave down. Okay, so this is concave down starting at 0. Then we hit pi over 2, and at pi over 2, but not including pi over 2, we are concave down, and then we hit that inflection point. Okay, then it's concave up from here to here, and then right there's my inflection point again. It starts being concave down again at 3 pi over 2, but not including 3 pi over 2 because an inflection point does not determine concavity, it just changes it. And right here, if we're including 2 pi, it's still at this very moment concave down. So at 2 pi, we're including it concave down. So I think most of us feel good about the numbers. It's just the brackets that might be kind of weird, but kind of weird is my middle name. It's Charles. It's actually Charles. When does g of x equal -1 on the same interval 0 to -2? Okay, well, -1 lives right here, so nothing, 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 u, nothing, nothing, nothing. So right here at 2, or at regular pi, we hit -1, and that's the only spot. Okay, so g of x is -1 when x is pi and only pi. Okay. Last but not least, is g of x an even or an odd function? If you don't remember the difference between even and odd function, an even function, okay, has a mirror image from the left to the right. So u would be even. An odd function is like if you were to draw out the left side, okay, like this. Okay, the right side is a 180 rotation, so like that. Okay, now cosine in its most natural form would continue looking like this. So it looks to me, and I know my picture is not the best, it looks to me if I were to cut directly down the y-axis and kind of like fold things over, the cosine falls on itself. It folds onto itself exactly. They're mirror images of each other. So cosine, generally speaking, is an even function. Okay, cosine is an even function. If for funsies I wanted to go back here and look at sine in its most natural form, sine is going to be an odd function, because if I were to take this, spin it upside down, I would get the same exact picture. So yeah, and so there's other words that we saw in the last problem that I just moved away from as far as horizontal and vertical displacement. Since cosine is an x value, that represents horizontal displacement. So if I were to draw the unit circle and I don't have enough space and show all those lines, you know, there's all these things that you're going to see on this test. You know, again, when I made this a couple weeks ago, I looked at the test, I looked at the progress check, and I just kind of created problems similar to what you're looking at. So it doesn't mean that you will see a problem that says, is cosine even or odd? You might see a problem that's like, does cosine represent vertical displacement or horizontal displacement or something to the like? And you're just going to have to try to remember what we did here and know that sine and cosine, although similar in nature, are also very different in nature. So fun stuff. Very fun. All right, let's move my face again. Will I be able to put my face anywhere? Yes. I hate this problem. The AP pre-calc tests have this problem everywhere. Is this the problem I hate? No, I don't hate this problem. I think it's the next problem that I hate. So I'm sorry, I take it back. Problem, I love you. Now, what we wrote down 2 slides ago is this guy right here. It's asking us to find sine x and cosine x. Let's not overthink this. It's giving us a picture that is not a unit circle, but it's kind of a unit circle. And it's saying the figure below gives a circle in the xy plane, the center of the origin, the angle is theta in standard position, blah, 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 blah. It's asking us to find sine theta, cos theta, sketch the graph of the point to the xi. Okay, great. Now, what this is asking us to do is the old school way of doing things, and I'm just going to write stuff here and I'm going to erase in a second, is sine theta is the same thing as y. Ooh. Sine theta is y over r. Now, when r is 1, that's where we get sine theta equals y over 1. Why? That's why we were able to put that point up there 2 slides ago, because, you know, we were assuming that, you know, there's an invisible 1 for r. But that doesn't happen here. What happens here is the y value, if I were to multiply r to both sides, the y value becomes sine theta equals y. So whenever I have a unit circle where r is not 1, I'm not using the point cos theta sine theta. I'm using the point r sine theta. And if you're wondering, well, isn't cosine theta x over r? Which means that multiply both sides by r cos, this is your voice, r cos theta is x. Wouldn't we have that? You're absolutely right. Good job. Good job. If that's what you were saying, if you were saying that with me, good for you. Good for you. All right. Now, I'm stupid because I didn't need to do that. I should have just kept the original. I just gave you a little bit extra. You're welcome. Sine theta is y over r. So I'm not sure I needed to do that. I don't know. Maybe that'll come into play here. I don't know. But sine theta is y over r. All right, so that point's not useful. If I'm looking at this point right here as my point for basis, and if I'm looking at, so you would be like an x, you would be my y. My r is the radius. My r is 8. How do I know that? Because when this is flat here, my radius is the center to the end of the circle. My r is 8. So this is literally as simple as saying positive 5.292 divided by 8. So all that fluff that I had here like a minute ago was not necessary for this problem. I think I was just overthinking it. And same thing with cosine. Cosine theta is x over r. My x value is negative 6 over 8. I think I can simplify this one, even though I have no clue what that's going to simplify to. But this is going to simplify to negative 3/4. Much friendlier. Much friendlier. Now, sketch the graph of the point to the x-axis on 0 to pi. All right, so pretty much what I'm asking here. Sketch the graph of the point to the x-axis. What am I asking here? This is the problem when I make these things like a month ago and I don't remember what the question is. The graph of the point to the x-axis on 0 pi. I wonder if I don't really need to sketch the graph. I mean, this is the point to the x-axis. So I'm looking at vertical displacement here, which is a y value. Okay. So y, and maybe now this will finally come in handy. Y is, oh, I know what I'm asking. Okay, so y is r sine theta. R is 8. Sine theta. So I'm not necessarily talking about this point. I'm talking about the x-axis in general. Okay. All right. So I'm asking you, sketch the graph of the point to the x-axis on 0 to pi. So I'm asking you to basically sketch the graph y equals 8 sine theta. So, okay, really stupid question by me. I could have probably worded it a lot better, but knowing me, I worded it the way I worded it because it's very similar to the wording on the test that you'll see. So 8 sine theta is the same thing as regular sine theta that we saw 2 slides or whatever ago, but we go up to 8 now, and we bottom out at negative 8. Okay, 8 sine theta still has a period of 2 pi with the amplitude being 8. So the period is still 2 pi. So it's going to repeat at 2 pi, which means its magic happens at regular pi. We always have 3 pi over 2. Let's scooch this over just a teensy bit because my graph could be a little bit better. And then this is regular pi over 2. Sine, as you know, starts at 0, 0. Peaks out at the top of its amplitude, hits the x-axis again at pi, bottoms out at negative 8, repeats the process at 2 pi. And that is the graph of the point to the x-axis on 0 to pi. All right, so the problem before, I was all complainy about thinking that it was the awful problem. This is the problem that I hate. So this is a very typical AP prep, problem that you'll see. I've done a couple of them on my YouTube, and I don't like them at all ever. But let's go over it. We are given an angle theta. There it is. In standard position as shown in the figure. The function g is given to us by g of a equals cos a. All right, so g is a regular cosine function. And knowing that this is going to be a little on the sloppy side, okay, cosine looks like this. It's actually not sloppy at all. But what we have is we have magic happening at pi over 2. We have magic happening at pi. We have magic happening at 3 pi over 2. And then 2 pi repeat. All right. Picture's drawn. For the angle alpha, which is not shown, alpha is in between theta and 3 pi over 2. So if alpha is in between theta and 3 pi over 2, then if I were to take an alpha and spin alpha around, it'll land like maybe somewhere over here. So you would be my alpha and you would be my theta. Now all the magic happens between like theta, which is in quadrant 3, and quadrant 3 begins at pi and ends at 3 pi over 2. So if I were to compare this picture to my cosine picture over here, like here's theta, there's theta, a little after theta, but maybe not quite halfway through according to the picture that I drew, we have theta. So theta might live like right around here somewhere. Somewhere after it, and it could be immediately after it, it could be way after it, at any point after theta, but before 3 pi over 2, we have alpha. Now, this is the y-axis, or in our case, the g, that's an F, the g of what, A axis? And it looks to me that alpha, no matter where I put it, no matter where I put this alpha, if I put it here, 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 if I put it here, 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 no matter what, alpha, as far as its y value is concerned, is going to be higher than theta. In other words, no matter what, g of alpha is going to be a higher number, or g of alpha is going to be greater than g of theta, no matter where I put it. Okay, so g of alpha is going to be greater than g of theta. So I don't know. It's a problem I really don't like. It's just, I don't know, it's just very bizarre, but you'll probably see it somewhere, whether it's on this test or an AP test or some other type of test, you'll see it somewhere. So we did it. And it was so much fun. Moving my face again. I need to do a better job making these slideshow things. The green coordinate is -2 to root 3. Okay, so we'll say that. -2 to root 3 is the green coordinate. What is the angle created by the positive x-axis rotated counterclockwise to the point? All right, so here's the positive x-axis. It looks to me that we have 4, 0 here. And so the angle from the positive x-axis to that point is what it's asking us. So we'll call you theta. Okay, so we need to find the theta of that. Well, I find the theta by thinking, all right, well, a couple problems ago, the old guy accidentally wrote a bunch of stuff over here that he found out that was useless. Well, now it's useful again. If I'm having to deal with a unit circle, where my values are like, or my unit circle where my radius is not 1, and I'm given xy values, let's view that as r cos theta, r sine theta, like that. Okay, so you are an x value, you are a y value. Okay, so basically what this means is r cos theta is x. R cos theta is -2. Now, before I even consider this, let's also use a little bit of common sense. I found out what r was. R was 4. So 4 cos theta equals -2. Divide both sides by 4, and cos theta equals, that's supposed to be a 4, -1/2. Now, the way I get rid of cosine so I can find out what theta is, which is the angle created by the blah, 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 I'm going to square root, or not square root, what am I thinking? I'm going to inverse cosine both sides. And so the inverse cosine of -1/2 is going to be negative 1/2 inverse cosine of negative 1/2 is going to be 2 pi over 3. And if you're thinking, all right, great, let's do the sine. No. Like, why would we do the sine? If we did the sine, we would end up getting the same exact number anyway. All this is asking for us to do is to find what theta is. Well, we just did that. Theta is the inverse cosine of negative 1 over 2. If we were to say r sine theta equals 2 pi 3 and then let r be 4 again and divide both sides by 4 and get whatever, we would end up taking the inverse sine of, what would that be? Root 3 over 2. And the inverse sine of root 3 over 2 is 2 pi over 3. Okay? So it doesn't really matter which way we do it. We did it. And that's what theta is. Theta is 2 pi over 3. Now, the blue guy, because we haven't done that yet, is the angle created by the positive x-axis rotated counterclockwise to the blue point is 2 pi over 4. What is the coordinate? So now we're dealing with this guy. Okay, so from here to here, and we'll call this alpha because, you know, me. Somebody not too long ago said that they remind me of Andrew Tate, and that was the biggest insult of my entire life. The angle created by the positive x-axis. Okay, so this is 5 pi over 4. Okay, so we need to find the point. Well, let's go back to here because now I need an x and a y. It's not a matter of me finding one of the thetas. I need to find an x and a y. So I know r is 4. I know theta is 5 pi over 4. So my point would be 4 cos 5 pi over 4 and 4 sine 5 pi over 4. Okay. Cosine of 5 pi over 4 is negative root 2 over 2. Sine of 5 pi over 4 is also negative root 2 over 2 because they live in quadrant 3. And quadrant 3, sine is negative, cosine is negative. So 4 times negative root 2 over 2, 4 over 2 becomes 2. So this just ends up being negative 2 root 2, negative 2 root 2 after I do the very, very, very basic math with fractions. And that kind of looks right. I mean, you know, this, first of all, 5 pi over 4 is right in between pi and 3 pi over 2. So it makes sense that if it's literally exactly in between, we're going to have the same exact number twice. So that's what we have here. It makes sense that they're both negative because we're in quadrant 3. You know, it all fits. It all fits. That's how you do it. All right, now we're going to sketch negative 4 cos pi x. Okay, so we are comparing this to a sinusoidal equation. So a couple of the things that we have to do, and actually what I'll do instead of sketching first is let me answer all of these guys. We're comparing this to something that's sinusoidal, which in this case, we don't have to worry about any shifting. All we have to worry about is the fact that there's a negative 4 in front of cosine now, which means the amplitude is 4. The amplitude is always positive. So if you're like, not negative 4, no, amplitude means very tippy top to the very bottom divided by 2. So it's like a literal height, not a number, so to speak. The period. Now, the way you figure out the period is you take the number in front of x, which is your frequency, and you do 2 pi divided by that number. So the frequency is pi, but the period is 2. And since I just said that, the frequency is pi, but the period is 2 means the frequency is pi. The midline is where am I going to have a horizontal line cutting this in half? Well, since I'm not adding or subtracting anything, the midline is going to be the x-axis, which is the equation y equals 0. Now I'm going to sketch this on, the interval between 0 and pi, 2 pi. So I'll put 2 pi there. I'll put regular pi there. Half and half, so pi over 2, 3 pi over 2, and for some reason I put 2 pi underneath. Usually cosine starts up here and goes like this. However, since that's negative, it's going to start down here and go like that. Okay, now since the amplitude is 4, it's going to start at -4 and peak out at +4. Okay, it's going to start at -4 and peak out at +4. Usually, this happens at 2 pi, the repeating process. But since the period is 2, this is going to happen at 2. And so this is going to be 1, and then this is going to be 1.5, and this is going to be 0.5. So me actually labeling this was a dumb idea because I'm not going to use these numbers. So you're going to be a half, you're going to be 1, you're going to be 1.5, so 3/2, and you're going to be 2. You're going to be 4, you're going to be -4. Since this is negative cosine, instead of starting at 0, 4, we start at 0, -4. It's going to cross the x-axis there. It's going to peak out at 4, excuse me, when x is 1, come back down, and bottom out and repeat the process at -4. So looks like this, looks like this, looks like this, looks like this. And then, you know, or fun stuff. Let's do another. Now we're kind of getting into sinusoidal territory where now we're dealing with shifts. So I like to compare this to the equation A, and since this is a sine, I'll use sine. Okay, B x minus C, close double parentheses, plus D. A is the amplitude. A is 2. Now, here's the thing. I know I set it up like this. Some teachers do it differently. B in front of x implies that there's something in front of x, and there's nothing in front of x but an invisible 1. So invisible 1 in front of x tells me that the frequency is 1, but the period is 2 pi. Now, the midline is D. So since this is going to shift up 1, or a vertical shift of +1, I go up 1, which tells me my midline is y equals 1. And since I have x minus c matching up with x minus pi, negative c is negative pi, which means positive c is positive pi. So I am having a positive horizontal shift of pi, or move to the right pi. All right. So a little rough draft. This is a sine, which starts at 0, 0. So again, rough draft. Okay, so I will go, hit a button there that I didn't mean to. Okay, let's scooch that over and let's try that again. I'm going to draw a rough draft, okay, of a regular sine function, which looks like this. Okay, all right. What I'm doing with this sine is the amplitude is 2. I'm not going to worry about that yet. The period is 2. 2 pi, I'm not going to worry about that yet. The midline is y equals 1. So I'm going to scooch this up 1. Okay, so you are now 1. The amplitude is 2, which tells me that this peaks out at 3 and bottoms out at -1. So I know my picture's not the best, but you get the idea. The period is 2 pi, so this does repeat the process at 2 pi, so that's good news. The horizontal shift, though, the horizontal shift, so let me get rid of this, has me going right pi. So right pi, which means I start at pi and I repeat at 3 pi. All right, so let's draw this guy a little over. Okay, let's draw this guy a little over, more than usual. We have pi, 2 pi, 3 pi, and we'll put in 4 pi just for funsies because I already gave this that much room. Halves and halves and halves and halves and halves and halves and halves. Let me scooch these over so it's a little bit more clear as to what I'm doing. I think that's fine. Here, let me erase these. I didn't do a good job placing them. So let me scooch these over. All right. So you were regular pi. You're going to be 2 pi. You're going to be 3 pi. You're going to be 4 pi. Okay. I peak out at 3. So 1, 2, 3. I bottom out at -1. So -1. I midline at regular 1. And I shift right pi. So I am going to draw my midline as a horizontal line going through 1. My new starting point is here. Okay. At pi. So, and since the period is 2 pi, we repeat at 3 pi. So we go up here, okay, and bottom down at 2 pi. I keep screwing that up. Okay, peak out after half of a pi. After a full pi, we return to where we were, and then come down to -1, and then come back out. Half a pi later, peak up, and then come down, and then bottom out. Okay? All right. And I can kind of go reverse here and say bottom out down here and start there. So this is what we're going to have. This is 1,000% not my best graph at all. I mean, this is not good, but hopefully you get the idea. Oof. Yeah, not my best work. Not my best work. All right. Not my best work at all. Sketch. Ugh. All right. Well, first off, this isn't even the form that I want it to be in. The form that it's supposed to be in is supposed to be A cos B parentheses x, that's supposed to be an x, minus C, close it, plus D. What I have to do, and this is weird, okay, weird problem alert, is I have to basically keep everything as is, but rewrite the inside of the parentheses. Now, the way a sinusoidal function works or looks is B parentheses x, which means while in the parentheses, there's not supposed to be anything inside the parentheses in front of x. So I have to factor out a 4, which, you know, doesn't seem like a big deal until I get to this guy. When I factor a number from something else, I divide that number out. So if I divide 4 from -2, I end up with -half of a pi. Okay? Strange. But I've seen stranger things. The TV show. You're my amplitude. You're my frequency. If my frequency is 4, then the way I find my period is I do 2 pi divided by 4, which gets me pi over 2. I'm not going to want to graph this. The midline is -3. So y equals -3. My horizontal shift has me saying, all right, well, -c is half of a pi, which means my horizontal shift has me going positive half of a pi or right half of a pi. And if I have an amplitude of 2 and a midline of -3, my minimum value is I start at -3 and go down 2, so my minimum value is y is -5. So, all right, rough draft alert. Okay, rough draft alert. This is a regular cosine. Regular cosines are supposed to start up here, okay, bottom out, repeat. All right, I am moving this down. Let's see if I probably should move this up because I have to move it down quite a bit. I am moving this down 3, which falls completely below the x-axis. Okay, if my midline is -3 and my amplitude is 2, that means I peak out at -1 and bottom out at -4. I shift half of a pi. Okay, so I move right half of a pi. Okay, so pi over 2. My period is also pi over 2, which means every pi over 2, it repeats the process. So at pi, it's going to repeat. So if I scooch this over a little bit more and clean this up a little bit, okay, we have pi over 2 is where it begins. And every period, it repeats a cycle, which means at pi, it's going to repeat another cycle, which means this starts normally at 0. Oh, that's not bad. Why do I know that? Well, if every period is pi over 2 and I start at pi over 2, that means working right, I just move over half of a pi, and also working left, I move over half of a pi. So this really has no effect in my horizontal shift, really. So I'm going to draw a regular looking graph, but I'm going to keep everything under the x-axis. Okay. I'm going to really want to spread this out wide, so I will call you half of a pi. I will call you, that's a quarter, which I do want a quarter, so I'll scooch that over here. So I'll call you half of a pi. A quarter of a pi will live right there. 3/4 of a pi will live here. And that's a pi. And then half, 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 half. Okay. -1, -2, -3, -4, -5. My midline occurs at -3. As we learned that shifting it to the right, pi over 2 does really nothing. So it repeats, goes down, and then comes back up, goes down and comes back up. Okay, which means it bottoms out completely at pi over 4. Okay, comes back up, bottoms out completely at 3 pi over 4, and every 1/8 of a pi kind of is where I cross the x-axis. This is me drawing it out. Slightly better looking than the last one that I did. And by slightly, I mean like, a lot. A lot. All right, let's move my phase because we need to see the pirate ship. All right, so pirate ship. Okay, it goes like this. And watch the thingy. Watch the thingy. While pirate ship goes like this, that means the height goes like this. Now, multitasking. Height goes like this. So what we're dealing with is a sinusoidal function where as we move along, the height is going to go up, down, up, down, up, down, up, down. For 40 seconds, a pirate ship ride follows the same sinusoidal pattern, completing 8 cycles where the center of the ship reaches a maximum height of 55 feet and the minimum height of 5 feet off the ground. Not of the ground, but off the ground. Sketch a graph assuming the initial height is 5 feet. All right, well, 40 seconds, it completes 8 cycles. 40 seconds, it completes 8 cycles. What that means is every cycle is 5 seconds long. So 5, 10, 15, 20, yada, yada, yada. Okay. It bottoms out at 5 and peaks out at 55 and begins at the bottom. The initial height is 5. So what's going to happen is this is basically like a sine function shifted up where, or maybe a negative cosine function. Am I going to have to come up with an equation for this? No. So I don't have to worry too much, but it repeats at 5 and then repeats at 10 and then repeats at 15, and then repeats at 20, and so on and so forth, and so on and so forth. Okay. My period in this case is basically the amount of total time that I have. divided by the number of cycles that I'm dealing with. Okay, the number of cycles that I'm dealing with. In this case, 40 is my total time, and it takes 8 cycles, so my period is 5, and you can see that with the graph. Okay, the graph makes that obvious, but I just wanted to go through the process anyway. Now, what does that make the frequency? Well, normally I ask you to take the frequency, if I give you the equation, and find the period. And what you do is you do 2 pi over the frequency. Well, that also means if period is 2 pi over the frequency, all right, divide both sides by p, multiply both sides by f. That also means that the frequency can be calculated by doing 2 pi over the period, which is 5. So the frequency is going to be 2 pi over 5. So a little bit of proportionality going on there. Crisscross applesauce stuff going on there. Yippity-yay. Now the altitude. Oh, the devil's tempting you to say 50, isn't he? He's tempting you to say 50 because you're thinking, yes, the very tippy top minus the very bottomy bottom, that's my altitude. No, that's my total displacement, I guess you could say. But altitude is you take the tippy top minus the bitty bottom and divide by 2, which is going to be 55 minus 5 is 50. 50 divided by 2 is 25. Okay, careful. What is the midline? Well, the midline is found by you crossing exactly through the middle of the very bottom to the tippy top, which is basically the average. So if you do 55 plus 5 and divide that by 2, you get the midline, which is going to be the equation y equals 30. Okay? No equation needed. Don't need to come up with an equation for that one. Fun stuff. Pirate ships. Pirate ships. Oh, look at that. I do not need to move my face, and I won't. Now, let's look at what we're doing with. We have to write a sine and cosine equation for this graph. This is what I'm going to do first. I know sine starts at 0, 0, and goes, up, down, up, down, up, down. I know cosine starts at the very maximum and then goes down and repeats every maximum. Why don't I come up with the cosine equation first for this one and then turn it into sine? So I'm going to use y equals the typical sinusoidal function, a cosine parentheses b x minus c, close it, plus d. A is the amplitude. How do I find the amplitude? Well, the very tippy top happens at -1. The very bottomy bottom happens at -7. So the amplitude is going to be -1, actually better yet, -7 minus -1 over 2, which is going to be -6 over 2. So the amplitude is -3, but it's got to be positive, so the absolute value is +3. Okay, so probably did a bit too much there. That's all right. A is regular 3. I think I was thinking midline thoughts when I did this, but I'll get there. B represents the frequency. Now, in order to find the frequency, we just found out that the frequency can be found by doing 2 pi over the period. So let's find the period. The period is 2 pi. So the frequency is going to be 2 pi over 2 pi. How do I know that? Very tippy top to the very tippy... Oh, I lied. I'm a liar. It is not 2 pi over 2 pi. It's 2 pi over regular pi, which means the frequency for this guy is 2. Oh, careful. That was a close one. Phew. Since I'm using cosine, and cosine starts at the very maximum, that means I have no horizontal shift. Okay, so C is 0. Thank God for that. Now, D represents the midline. The midline is going to be in between -7 and -1, so that's what I was thinking. So -7 plus -1 is going to be -8 divided by 2, which is -4. So D is -4. So A is 3. The frequency is 2, which means B is 2, C is 0, and D is -4. So Y equals A, which I found out is 3, cosine, parentheses, B, which is 2, close parentheses, x minus 0, so I'll clean that up, plus negative 4, and I'll clean that up. So my cosine function, which I'll write in purple. I never use purple enough, except that I kind of did in this one a bunch of times. Y equals 3 cosine. That's useless, so just 2x plus negative minus 4. There is my cosine function. Now, what I could do is I could follow the same process and find sine, but you probably don't need me to do that. I'm just going to remind you of a fun fact. Remember, cosine of theta is the same exact thing as sine of pi over 2 minus theta. So, what that means, if cosine of theta is sine pi over 2 minus theta, then cosine 2x is the same thing as sine pi over 2 minus 2x. So I can rewrite this guy as y equals 3, because the amplitude won't change. Instead of cosine, if cosine theta is pi over 2 minus theta, then cosine 2x is sine pi over 2 minus 2x. Just replace the theta with 2x. The midline won't change either. So again, if I wanted to, I could have gone out through this whole process and done the same thing and be like, okay, well, sine is supposed to start over here or over here, and then you kind of work your way around trying to figure this out, but this works out just as well. Okay? And if we were to use this process with sine, we'd find out we'd have the same amplitude. We'd have the same frequency. The only thing that really would change is the horizontal phase shift. Everything else is exactly the same, but I'm just kind of using this little trick to make life a little bit easier, because why the H not? A grandfather clock has a pendulum that swings left to right continuously. It takes the pendulum 1 second to get to each side. I wonder why. The pendulum is 36 inches off the ground at its lowest point, 42 inches off the ground at its highest point, and the hour begins when the pendulum is at its lowest point. Write a sinusoidal equation describing the situation. All right, what I'm going to do is if the hour begins when the pendulum's at its lowest point, I'm going to approach this not from a sine or a cosine, but from a negative cosine point of view, because cosine starts up here and works its way down. However, negative cosine starts at the bottom and works its way up like this. So we're basically at its lowest point, whatever. So I'm going to use negative cosine. So I'm going to compare this to y equals negative a cosine bx minus c, close it, plus d. All right, that's how I'm going to handle this one. So let's find each part. A is going to be, so it's 36 inches off at its lowest, 72 or 42 at its highest. So we'll do 42 minus 36 all over 2 is going to give us 6 over 2, which is 3. So the amplitude is 3. Remember, amplitude is not the highest point to the lowest point, but halfway in between highest to lowest. That's why I'm using this equation, which kind of looks like midpoint-ish to figure it out. B. So the frequency is 1 because it's 1 second. You know that. So B is going to be 2 pi over 1. So the frequency is 2 pi over 1, which is just 2 pi. All right, I can handle that one. I mean, the period is 1, not the frequency. I'm sorry, the period is 1, not the frequency. Since I'm starting with negative cosine, I have no horizontal phase shift, so C is going to be 0. And D is going to be my midline. Now, if at the very bottom it's 36 inches and then it peaks out at 42, halfway is going to be the average. So 42 plus 36 over 2 is going to end up being in between, that's 39. So the equation that I'll use, and let's do C of t for clock. C of t is going to equal negative 3 cosine, close it, b, which was 2 pi, parentheses, x minus 0, so I'll fix that in a minute, close it, plus 39. So let's clean this up. C of t equals negative 3 cos, I don't need that, 2 pi x, plus 39. And so when I graph that, it starts out from the bottom and then if you've made it this far, I appreciate you. Once again, I have to move my face. The table demonstrates a sine pattern. Oh, now we have to do sine. What am I supposed to do? Okay, so lots of stuff, and then at the very end, I have to come up with an equation. So let me graph what I see. I'm way the heck over here. 1, 2, 3 is my highest, and then I go down to 1, 2, 3, 4, 5, 6, 7. I start at 1, 2, 3, 4, 5, go all the way to 1, 2, 3, 4. Why did I do that? 9. So 5 is negative 7. So 5 is negative 7. 6 is negative 2. So up here, 7 is 3. 8 is negative 2. And 9 is negative 7. So we really, okay, so this is kind of weird where this is a picture that we have. It's not exact at all. But oh boy, do I have to be very, 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 very careful. And I'll explain why in a little bit. First off, this is amplitude, okay? This peaks out at 3, bottoms out at negative 7. So the amplitude is going to be 3 minus negative 7 all over 2, which is 10 over 2, which is 5. I can handle that. Looking at that, that makes sense. The period, okay, it looks like the process repeats every 4 seconds. Okay, so the period is going to be 4. The frequency is going to be 2 pi over 4, which is pi over 2. The midline is found by doing this plus this, dividing it by 2. So 3 minus 7 divided by 2 is negative 4 divided by 2, which is negative 2. So the midline is going to be the equation y equals negative 2. The horizontal shift. Now, be careful. Be careful. The horizontal shift, it's tempting to say, oh, well, don't you go right 5 because, that's where you start? No, that's where a negative cosine would start. Sine starts when everything is right in the middle and then works its way up. Okay, the regular sine graph looks like this, right? So we wouldn't start down at the bottom. We would start here. Okay, so what this guy is, and the way we get to this guy, is not right 5, but rather right 6. So the horizontal shift is going to be positive 6. Very, very, very careful. So if I'm comparing this to y equals a sine, parentheses b, parentheses x minus c, close it, plus d, then I'm going to have y equals a, which is my amplitude, 5, sine, close it, or open it rather, b, which is my frequency, is pi over 2, close it, x minus positive 6, so x minus 6, close it, plus negative 2, so since I don't have a ton of space, minus 2. Wacky stuff. All right, now moving on to this last one. It looks like, I believe, if I recall, this is the calculator one. There you are, Mr. Calculator. I see you. You are studying the motion of a simple harmonic oscillator. Okay, up and down, up and down, up and down, spring oscillator, whatever you want to call it, harmonic spring that cycles every 4 seconds. You have collected a table of values representing the height, h inches of the oscillator above a reference point. That's just poor grammar by me. The data is as follows. Write an equation in the form g of t equals a sine b t plus d. Now this is using sine reg. Okay, sinusoidal regression in our calculator. When it looks like this, we think sine reg thoughts. So the first thing that we're going to do is we're going to run to our calculator, plug all this information in, see what our calculator spits out, and write it down. All right, gang, it's time to do some calculator stuff. You ready? You ready? You ready? We're given a table of information, and we're going to use sinusoidal regression to figure out what that information is. So first things first, hit stat, hit edit, and let's type those numbers in from 0. If I knew how to type, that would be great. All the way up to 9, like so. And then we have 6, and then we have 10.2, and then we have 6, and then we have 1.8, and then we have 6, and then we have 10.2, and then we have 6, and then we have 1.8, and then we have 6, and then we have 10.2. I wish I chose a smaller table, but you know what? We did it, and boy, did we have fun. All right, sinusoidal regression, stat, calc. Go all the way down until you see it. Okay. Usually I make the joke that we shouldn't sin reg, we should sin never, but that has nothing to do with this. Don't worry about the iterations. Don't worry about that. Don't worry about the period. We are going to store this puppy into our calculator because we're going to need it a bunch of times. So hit vars, hit function. Okay, we'll pick the first one and calculate. All right, so look at that. The first guy, and by the way, this is almost exactly what the problem gave us. However, you might be thinking, wait a minute, A, B, C, D, I don't remember that. We were given A and then B, but no C over here. Well, we're in luck. C that looks awful, but E negative 14 is 0. So there is no phase shift for this guy. It's 0, it's 0, it's 0. So A is 4.2. We'll round B to, well, wait a minute, 1.570. Isn't 1.570 pi over 2? Let's find out. Pi over 2. It is. Can I go back up? Can I go back up? Can I go back up? So let's sine reg again. Yeah, so there it is. So B is pi over 2, and D is just regular old 6. So let's put that all together. G, since I moved my face, G of T equals 4.2 sine pi over 2. That gross number that we got was pi over 2. Okay, T and then plus 6. Okay, all right. T again represents height. I probably should have used H for height, even though it says write this equation in the form G of T. I probably should have used height. That's all right, not the end of the world. We're using G of T. But I have to find the height as time T equals 12 seconds. So I'm going to find G of 12, which means I could use my table here, but I'm going to let my calculator do all the work. All right, B is asking us to predict a height as time equals 12 seconds. So the easiest thing to do is, since we stored this already into y equals, is why don't we go to second graph and scroll down to 12 and find out that the answer is just 6. Okay, so in this case, 6 inches. So 6 inches off the ground. All right, let's keep moving. Keep moving. Let's move my face one last time. Maybe all of these are calculator problems. What was I still have the equation in my calculator. No need to worry. How many times will the height be 5.5 inches in the first 10 seconds? All right. So calculator. How many times will the height be 5.5 inches in the first 10 seconds? Well, we haven't graphed this yet, so let's graph it. Now, let's get rid of the negative time because we don't need negative time. And so when we graph this, we can see, where things go up and down. But I need specifically how many times we will hit 5.5. And I really can't see this in such a small space. So what I'm going to do is I'm going to use another y equation and make it 5.5. Okay, because the y equation represents height, and so it's basically saying, hey, when is the height 5.5? Well, now when we hit graph, this is the first 10 seconds. It just misses 1, 2, 3, 4, and just misses again. So the answer for this one is 4. Not once, not twice, not thrice, but 4 times. After the 10-second mark, when will the height be 6.17 inches? Okay, so in order for us to do this next one, what I really need to do, if I care about what's going on after 10 seconds, is I'm going to set my window to 10. Okay, I'm going to go back to y equals, and I don't care about 5.5 anymore. I care about 4.17. Okay, so now that I'm at 10 and I have 4.17, let's hit graph. And it happens pretty much right away. So I'm going to hit second, trace, and hit intersect, because where these two lines intersect is wherever my height hits 4.17. So let's move to the left until we go to the left of the very first intersection, like right there. Enter. Move to the right. Enter. Enter. And it gives us 10.28, blah, blah, blah. So we'll say 10.287. Yeah, because I think that's a 0 there. I don't know. I really can't tell. My eyes are so bad. At 10.287 seconds. So didn't have to wait long at all. Okay, after the 10-second mark. So not long at all. Graphically, don't need my calculator for this one. Graphically, what does g of t equals 6 represents? Well, if you remember what the equation was, plus 6 was our d. That, my dear boys and girls, is the midline. Okay, graphically, that represents the midline. Easy peasy. That's where my line cuts horizontally my entire graph in half. And last but not least, I will need a calculator for this one. Find the average rate of change for the first 22.2 seconds. So that's going to require us taking g of 22.2, close it, minus g of 0 over 22.2 minus 0. The old, we've seen this formula 1,000 times. So let's throw that in our calculator and rack this thing up. All right, last but not least with this guy, we need to find the average rate of change. I still have my equation right there. Okay, so let's do this. Let's find out what g of 22.2 is and g of 0 is, and just kind of commit that to memory. All right, so g of, well, first off, if I'm going to do this, I need to fix my window so that I can get to 22.2. So I'll hit 30 for x max. If I hit graph, there we are. Okay, I really don't care about u, so let me clear u. Don't need u anymore. I'm going to find the value at 22.2. And let's memorize that. That is 4.7021. So 4.702. So memorize 4.702. All right. Now, when we care about 0, so I could just go to table, up second graph, not regular graph, second graph, go up, and we have 6 when x is 0. So the two numbers that I have to memorize were, what was it, 4.702, 4.702 minus g of 0, which was 6. That's going to be my numerator. Divide that by 22.2 minus 0, so just 22.2. Negative 0.058, blah, 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 blah. So we'll say negative 0.058, and that's it. Negative 0.056? 58. And what are we dealing with? Inches per second is our rate. So This doesn't cover every single problem you should expect to see on Progress Check A for Unit 3, but it covers a lot of it, and this should help you understand everything. If you watch this and you're like, boy, oh boy, I'm still not sure. I really wish some guy had videos of where I could be retaught all this stuff. Boy, are you in luck. Just type out Math Teacher Code Unit 3 reteaching and you'll find it. You'll find it. So, as always, thank you for watching. Thank you for following along and having fun with me. And that'll do it for this one. Bye.